The next part of Mod 7 is the law of cosines, which is another way of solving a triangle. We use this technique when we know two sides and the included angle, which is side, angle, side, or if we know all three sides, which is side, side, side. Then we use the law of cosines in order to solve our triangle. The law of cosines has three different forms. As you can see, we have a squared equals b squared plus c squared minus 2bc times the cosine of a. We have b squared equals a squared plus c squared minus 2ac times the cosine of b, or c squared equals a squared plus b squared minus 2ab times the cosine of c. The version that you choose is dependent on what information you have. Our first example for the law of cosines says given triangle ABC with angle A equaling 33 degrees, side B equals 53, and side C equals 29, solve the triangle. Carry out intermediate computations to at least 4 decimal places and round the answer to the 10th. So when you are looking at these problems and you need to decide which version of the formula to use, if you are given an angle measure, then that will determine which version to use. Because we are given angle A, we must use the version that has the cosine of angle A in it. So the version that we will be using is a squared equals b squared plus c squared minus 2bc times the cosine of A. So then putting all of our pieces into place, what this will force us to do is find side A. So we'll set a squared equals side B is 53 squared, side C is 29 squared, minus 2 times 53 times 29 times the cosine of our angle A that we were given, which is 33. So now, as we do the arithmetic on this formula, we will have 53 squared is 2809, 29 squared is 841, 2 times 53 times 29 gives us minus 3,074 times the cosine of 33. What I'm going to do now is put these two like terms together, the 2809 and the 841. This will now give me 3650 minus 3,074 times the cosine of 33. We have to multiply before we subtract. So what you can do is when you're putting it in your calculator, put in the 3,650 minus, and then put this in a set of parentheses. 3,074 times the cosine of 33 in a set of parentheses. If you do that, your a squared winds up being 1,071.926674. But that's a squared. We need a. So do the square root of both sides, and you get a equals 32.7 because we are supposed to round to the 10th. So now we know all three of our sides. We only know one of the angles. So we need to find angle B and angle C. The thing is that it is possible on these problems to have an ambiguous case for the law of sines. So it's dangerous to go back to the law of sines. I recommend that you stick with the law of cosines to find your first missing angle. So I'm going to do that, and I'm just going to go alphabetically and find angle B. If I'm finding angle B, then the version of the law of cosines that I need to use is b squared equals a squared plus c squared minus 2ac times the cosine of angle B. Putting our values into place, B is 53 squared equals, we just found A to be 32.7 squared, plus C is 29 squared minus 2 times 32.7 times 29 times the cosine of B. Well, 53 squared is 2809. 32.7 squared is 1069.29. 29 squared is 841. Minus, take 2 times the 32.7 times the 29, you will get 1896.6 times the cosine of B. We are solving for B. That means that we need to get the cosine of B by itself. So the first thing I'm going to do is put these two like terms together. And in doing that, I get 1910.29 minus 1896.6 times the cosine of B. In order to solve for that term that has the B in it, I am going to need to subtract the 1910.29 from both sides. In doing that, I will get 898.71 equals negative 1896.6 times the cosine of B. Now, to get the cosine of B by itself, we're going to divide by the 1896.6 and we now have negative 0.4738532211 equals the cosine of B. Well, if I know what the cosine equals, but I need to know what B equals, then I need to do the inverse cosine of that decimal. And that will equal B. So we wind up with an angle B of 118.3 degrees. So now we know all three sides. We know two of our three angles. What's left to do is find angle C. So angle C, you can just do the sum of the angles of the triangle are 180. Take 180 minus angle A, which was 33, minus angle B, which is 118.3, and you get angle C is 28.7 degrees. For example 6, we are going to solve triangle ABC if side A is 43, side B is 61, and side C is 63. In this case, we know all three of the sides, and we need to find the three angles. You can choose to find whichever angle you want to first. I'm going alphabetically, like I've been doing. So if I want to find angle A, then I need to use the version of the law that has cosine of A in it. So I need to use the A squared equals B squared plus C squared minus 2BC times the cosine of angle A. Putting our numbers into position, we will have 43 squared equals 61 squared plus 63 squared minus 2 times 61 times 63 times the cosine of A. Well, 43 squared is 1849. 61 squared is 3271. 63 squared is 3969. 2 times 61 times 63 gives us 7686 times the cosine of A. Putting my like terms together here, I will have 1849 equals 7690 minus 7686 times the cosine of A. Subtract 7690 on both sides. You will get negative 5841 equals negative 7686 times the cosine of A. Divide by the negative 7686. And so we have 0.759953162 equals the cosine of A. So A has to equal the inverse cosine or the arc sine of our decimal. So A comes out to be 40.5 degrees. I'm going to choose to find angle B next, which means I need the version that says B squared equals A squared plus C squared minus 2AC cosine of angle B. Putting our numbers into position, we will have 61 squared equals 43 squared plus 63 squared minus 2 times 43 times 63 times the cosine of B. 61 squared is 3271. 43 squared is 1849. 63 squared is 3969. Minus 2 times 43 times 63 gives me 5418 times the cosine of B. Put our like terms together, we're going to have 3271 equals 5818 minus 5418 times the cosine of B. Subtract the 5818. So we get negative 2097 equals negative 5418 times the cosine of B. Divide both sides by the negative 5418. And we get 0.387043189 equals the cosine of B. So B equals the arcsine of our decimal. So angle B equals 67.2 degrees. Now that we know two of the three angles, we can find the third angle, C, by taking 180 minus 40.5 minus 67.2, and we get an angle C of 72.3 degrees.